Finally, I'm going to demonstrate how to do sedimentation. This is done usually on large animal parasites because the eggs of those parasites are too heavy to float. So I have my 2-gram sample. I'm just going to add some water to this sample. Once my container is just filled with water, I'm going to mix the sample. I'm going to take some gauze and place it over a clean container and just strain my sample through. Go ahead and discard all of this. Then I'm going to pour that sample into another container. I'm going to fill it until there's just a little bit left up at the top. Put the top on it, and then I'm going to centrifuge the sample. Okay, so our centrifuge has a setting for fecals. So I'm just going to put it on that setting and let this spin for about 5. Once this solution has spun for 5 minutes, it'll look like this. So I'm just going to take off all this extra fluid. You can either pour it or pipette it out. I'm just going to pipette it out. I pipetted the extra fluid off without disturbing the sediment down at the bottom. So I'm just going to take a fecal loop and take the first layer off of this sample. I'm going to just place this on a slide. Then I'll place a cover slip over the sample and then just examine the sample for parasites. All right, that is it for this video.
These are the items we require in the stool concentration technique. We need the stool sample, the fine mesh of pore size 350 to 450 micrometer, the 15 ml centrifuge tube, a glass applicator for emulsifying the stool sample, that's the beaker for the filtrate, then 10% formal saline for mixing the stool, then diethyl ether. Add 10% formal saline to the stool, about a gram of the stool sample. Emulsify the stool sample with the applicator. Emulsify it very well to get a smooth suspension. Sieve the stool sample through the fine mesh into the beaker. Discard the stool debris. The debris is discarded under the tap water because it has been disinfected already with the formalin. Transfer 7 ml of stool filtrate into the 15 ml centrifuge tube. Rinse whatever is left in the beaker into the centrifuge tube. Add 3 ml of diethyl ether to the 7 ml of the stool filtrate in the 15 ml centrifuge tube, making a total of 10 ml. And you will see 2 layers, the ether layer and then the formal saline layer. Cover the centrifuge tube with the lid and mix the 2 layers very well. And this, the ether is to dissolve any fat which is present in the stool sample to release the parasites. So put it in the centrifuge tube, balancing it. Centrifuge at 1500 RPM for 2 to 5 minutes. Okay, take out the centrifuge tube and you will see 4 layers. The first layer is the ether layer, the debris layer, which is the insoluble part, and then the foamosaline layer, and then the sediment, which contains the parasite. Break through the debris layer and discard the first 3 layers under the tap water, which had already been treated with formalin. So the sediment will contain the parasites of the egg or the larvae, and then the cyst. Resuspend it with part of the foamosaline or saline, and use a disposable pipette to mix it very well and transfer a drop onto the microscope slide. Okay. Cover the drop of smear with the cover slip and examine it under the microscope using the ×10 objective, low light, and you are expected to see.
Ini sampel feses yang akan kita periksa dengan menggunakan metode sedimentasi. Kita akan memeriksa cacing fasciola atau Parasit dengan metode sedimentasi. Bahan pertama yaitu ethylene blue 1%, kemudian feses segar atau feses yang diawetkan dengan formalin, timbang digital, mikroskop, saringan untuk menyaring feses yang telah kita larutkan, dan beker glass sebagai wadah mengadukan feses dengan air. Proses pengerjaan: pertama, ambil sampel feses 3 mg, kemudian masukkan ke wadah beker glass dengan beker glass 500 ml, diaduk hingga larut, kemudian disaring tambah air secukupnya dan diamkan selama 5 menit. Kemudian buangkan cairan dan sisakan filter 10 ml. Kemudian tambahkan air kembali secukupnya sekitar 150 ml. Selanjutnya diamkan selama 5 menit dan kemudian selanjutnya setelah 5 menit buang lagi cairan atasnya hingga sisa 5 ml. Selanjutnya buang cairan bagian atas dan sisakan sekitar 5 ml. Kemudian asin pitrat yang tersisa 5 ml tuangkan ke plafon plat. Secukupnya. Kemudian teteskan ethylene blue 1% banyak 1 tetes. Kemudian selanjutnya periksa di bawah mikroskop pembesaran 40 sampai 200 kali. Selanjutnya kita melakukan pemeriksaan di bawah mikroskop. Ini bentuk gambaran telur cacing Parasit sp. Ini telur fasciola sp.
Metode apung, keuntungan dan kerugiannya seperti itu. Sama seperti tadi, sampel yang didapat ditambahkan air, kemudian setelah merata, kalau yang ini diletakkan pada tabung reaksi seleher tabungnya ya, kurang lebih segitu. Terus kemudian disentrifus. Setelah selesai sentrifus, diangkat. Nah, kemudian dibuang cairannya atau supernatannya, tapi endapannya jangan sampai terikut ya teman-teman. Nah, segitu saja sudah cukup. Kemudian ditambahkan gula atau garam jenuh seleher tabung lagi. Kemudian disentrifus kembali. Nanti setelah selesai disentrifus tidak dibuang supernatannya, tapi langsung ditambahkan gula atau garam jenuh lagi hingga cembung. Terus kita ambil cover gelas, diletakkan di bagian yang cembung tadi, ditunggu beberapa saat. Setelah itu cover gelas tadi diambil dengan tetesan airnya, kemudian diletakkan pada objek gelas, dan selanjutnya diamati di bawah mikroskop. Nah, itu adalah penampakan dengan metode apung ya. Lapangan pandangnya lebih bersih. Terima kasih sudah menonton. Assalamualaikum warahmatullahi wabarakatuh.
Equipment lists. To perform a McMaster, the following equipment is necessary. 2 beakers or plastic containers of at least 50 milliliters, a stirring device such as a spatula, a scale, a tea strainer, a Pasteur pipette and a rubber teat, the flotation solution, a measuring cylinder of at least 50 milliliters, a McMaster slide and a compound microscope. Sample preparation. Place an empty beaker on the scale and press the tare key. Add 2 grams of the sample to the beaker. It is important to weigh exactly 2 grams, as this may influence the accurate estimation of the fecal egg count. 30 milliliters of the flotation solution is added to the sample. Homogenize the sample using the spatula and pour the fecal suspension 3 times through a tea strainer to withhold the large debris. To obtain optimal results, it is crucial that the debris is firmly squeezed after the sample is sieved for the 3rd time. Once the debris is squeezed to dry, it can be discarded. Filling the slide will be simplified when it is rinsed and tapped on the surfaces. Before filling the slide, be sure that the external surfaces are clean and dry. Place the slide on a flat surface ready for filling. Homogenize the filtrate by pouring it 10 times from one beaker to another. Immediately, place the tip of the pipette in one corner of the chamber and squeeze the pipette until the chamber is full. Do not move the pipette across the opening of the chamber, as this may introduce air into the slide. Rehomogenize the filtrate and repeat the procedure for the 2nd chamber. Examination of the slide. Place the McMaster slide on the microscope table and allow it to stand for 2 minutes. The McMaster slide can be examined using a 100 times magnification. Start with focusing the microscope on one of the grid lines, after which you focus on the air bubbles, which are round in appearance and have a black outer ring and a clear center. Now systematically scan all the columns of both the chambers. Eggs that lie out the chambers are not to be counted. Cleaning of the samples. After the McMaster slide is examined, it can be reused by rinsing it.